Bismillahirrahmanirrahim. Our today topic is about nucleophilic substitution reaction. Last lecture में आपने SN2 पढ़ी थी type. Today it is SN1. How nucleophilic substitution reaction takes place in case of unimolecular case. One stands for one molecule. In this case we take tertiary alkyl halide. Tertiary alkyl halide means carbon is connected or joined on three sides with a carbon or alkyl group. This carbon is said to be as tertiary carbon because this carbon is forming three bonds with three carbon atoms. It is directly linked with three carbons. Such a carbon is called as tertiary carbon, and it is the case of tertiary butyl, and here I say tertiary butyl halide. Say it is X, and X stands for chloride, bromide and iodide. अब SN1 रिएक्शन में हमने ले लिया tertiary alkyl halide. Now what happens in this case? First of all, this reaction occurs in the presence of either aqueous acetone. Aqueous means acetone which is prepared in water, in aqueous medium. Either we take this or we take ethyl ether. Ethyl ether. And the reaction is reversible. What happens? First of all, a carbocation is formed. This halogen is electronegative by nature. This halogen gets electrons towards itself, and this carbon becomes electron deficient. So what happens? Halogen is left as such in the form of halide ion, and we get a carbocation in this way. A planar structure is formed, CH3, CH3 and CH3, and the deficiency of carbon is denoted by positive sign plus. अब आपने देख लिया कि this step is said to be as the slow step or rate determining step. In case of slow step, only one molecule is taking part. Since one molecule is taking part in slow step, that's why we say the order of reaction or molecularity is 1. Now what happens in the next case? Same carbocation, again write it in this way, CH3 CH3, ये tertiary butyl carbocation है. Now a nucleophile attacks on the carbon which is deficient by electron, and this nucleophile is strong nucleophile, as you have seen in the previous case, hydroxyl ion. This step is the fast step. In the fast step, hydroxyl ion attacks on the carbocation and the field is open. It can attack from this side, it can attack from this side, from either side. And that's why we get different type of structures. For example, if it will attack on this side, say OH will be on this side, जैसे कि halogen है, and you will get 50% retention structure. And if it attacks on this side, OH यहाँ पे है, जबकि लिविंग ग्रुप इस तरफ था, न्यूक्लियोफाइल लिविंग न्यूक्लियो, और OH इस डायरेक्शन में है, तो we get an inverted structure. So what happens? In first step, the attacking nucleophile, it attacks on this carbocation, and we get tertiary butyl alcohol, OH. it is said to be as tertiary butyl alcohol. तो इसमें हमारे पास क्या होता है न्यूक्लियोफिलिक सब्स्टिट्यूशन रिएक्शन में द रिएक्शन इज कंप्लीटेड और रिएक्शन कंप्लीट्स इन 2 steps. First step is called slow step or the rate determining step. In this step only one molecule is taking part. That's why we say the rate of reaction is directly proportional to the molar concentration of the reacting species, that is tertiary alkyl halide. यूँ लिख लें या आप इसको एक और वे में लिख लें rate is directly proportional to this tertiary butyl halide. ये हमारे पास आ गया रेट ऑफ रिएक्शन और रिएक्शन काइनेटिक्स. Now how you get retention structure and or inverted structure, उसका मैकेनिज्म थोड़ा सा हम देख लेते हैं. Now what is the mechanism? मैकेनिज्म जो है वो हमारे पास इस वे में है. टेक कार्बोकेटाइन, carbon deficient by electron, a tertiary butyl carbocation है हमारे पास. Now this carbon is electron deficient, so the nucleophile which is hydroxyl ion, it may attack on this side, OH negative. If it attacks on this side, इस साइड से अगर ये अटैक करता है तो what happens, we get this structure like this. CH3 CH3 CH3OH. Now this OH is on right side, just as you have seen in the previous case. This halogen is on right side, similarly OH is on right side, and this is tertiary butyl alcohol, and we get 50% retention configuration of the molecule. Configuration. रिटेंशन का मतलब है उसने अपनी जो शक्ल है या अपनी जो पोजीशन है वो चेंज नहीं की, उसी जगह पे रहा है. Now what happens if OH attacks on this side? Suppose इस वे में करने को, क्योंकि प्लेनर स्ट्रक्चर है कहीं से भी कर सकता है. It attacks on this side. At this time we will get a structure like this. इसको इसमें भी आप लिख सकते हैं, कोई मसला नहीं है. CH3 and OH. This OH is different from the X leaving group. Leaving group was on this side in the previous case. अब OH हमारे पास इस direction में है. तो this is the case that we have got 50% inverted configuration of the molecule. If it on this side, it will be the 50% retention configuration. If it attacks on this side, ये totally different है from halogens की side से, तो we get inverted. Inverted का मतलब उलट, कि X यहाँ पर था तो यहाँ पर OH होना चाहिए, यहाँ की बजाय अब हमें यहाँ मिल रहे हैं, तो it means ये उसका उलट है. तो that's why we say that it is the 50% inverted configuration. This was the case of tertiary carbon. Now what happens with secondary alkyl halides? सेकेंडरी एल्काइल हैलाइड। सेकेंडरी एल्काइल हैलाइड के बारे में जो हमारा है कि सेकेंडरी एल्काइल हैलाइड दे गिव both type of reaction SN2 and SN1. Both reaction nucleophilic substitution reactions are bimolecular as well as unimolecular. If they are bimolecular, it means one step mechanism कि एक ही में आपके पास बॉन्ड बनता भी है और टूटता भी है. And if it is SN1 reaction, it means it is unimolecular nucleophilic substitution reaction, and the reaction occurs in two steps. So secondary alkyl halide gives you say 50% SN2 and 50% SN1. Both are possible in this case. Thank you.